All right. All right, we ready? Get rid of porker. Okay. Get something else. We got lots of options. Lots of options. Who's Mac? Oh, it's Mac. All right, I got 18. I got 22 of us in the class. Okay, I'm going to start. 830053, 830053, 830053. Are you ready? Endorexo. Look up here. You can have your phone off if it helps you. You eventually will have to calculate. So, have to calculate as well. You got 8 seconds, 8 seconds. Last person.
Oh, yeah, yes.
Okay. So, if you did not have your phone call, listen up, guys. This is my quick review, and this is a good internal assessment of how much. This is a good internal assessment of how much you need to take, study time-wise on your own. But if you can do these without your phone, you're 100% fine. Okay. So, if you have a reactant here and a product here, and you start off with low energy for a reactant and high energy, you end up with high energy of a product. How did that energy get there? You put energy what? Into the reaction, right? So you go higher energy, so that's an endothermic process, delta H is positive. Good. Okay, keep going. Now, some of these you have to calculate. Who knows not have a calculator? All right, then get up and move. Go get one from the calculator box. Does temperature measure potential energy or kinetic energy? Hurry up. I'm not waiting on you. 20 seconds. 20 seconds.
Uh-oh. Oh.
All right, so the definition of temperature is what, guys? Average kinetic energy. Good. You need to participate fully, or I cannot utilize this as an assessment. I have to give a true assessment, which would be like a quiz or a test. Okay, so if you guys can give me effort, like sustainable effort, like you're showing your calculations, you're working things out in your calculator, I am fine. But as soon as you stop that, I can't continue to be nice like this. Okay? So calculate the initial temperature of a cup of coffee that cooled down to 20 degrees Celsius if the overall delta T is -34.
There was like 100 seconds up there.
It didn't say about the minute. Okay. Okay, guys, back up here. Keywords here. 1, the initial temperature cooled down to 20 degrees Celsius. The only option that was high and cooled down to 20 is what? Okay, so that's why that one's obvious. 2, the delta T was -34, so it ended at 20, so its initial was 34 degrees higher, so 20 plus 34 is what? 54. That one should have been like a 5-second question. Solve. This one's a little bit more difficult. Calculate the heat given off when 122.9 grams of copper cools from 178 degrees Celsius to 74. The specific heat capacity of copper is 0.385 joules per degree Celsius. Write it down. Yes, I should be using the calculator. All right, I'm gonna. Oh gosh, that's 10 people. Let's go.
Sorry.
That's that. Like, I can calculate as well. Okay, we're almost there. Okay, so guys, listen up. Shush. Between questions, I need your attention. So the negative should not be the only giveaway because the word released truly means negative. So I put that there, but I also need you to know that if I didn't have the negative and they were all positive values, the word released would still relate to the fact that it was an exothermic process. What you have though is what three variables here? M, C, and delta T. If you calculate your delta T is final minus initial. Final is 74, initial is 178. That's where the negative gets thrown in because negative 74 minus 178 is a negative number, and that's how we get a negative Q. Okay, so that is a what equation? I'm sorry. What calculation equation? Q equals MCAT. Thank you. Good. Solve. Calculate the heat necessary to raise 48 grams of water from 97 to 190 degrees Celsius. The specific heat capacity of water is that. I'm about to skip you.
Wait. Oh, well, if you skip, can you just keep calling? No.
Okay. So, I knew that you'd forget to do something, so I made this the right answer. But actually, look at this problem. Notice the temperature change goes from what to what? So, at 97 degrees Celsius, what is water's state of matter at 97 degrees Celsius? Liquid, because when does water vaporize?
You have to go to 100 and then go to.
Yeah, so you have liquid and then it goes to 190. At 190, what's the state of matter? So we underwent a what? Phase change. So everybody right now, draw a heat curve someplace. Draw a heat curve. Make sure your partner next to you is you're holding them accountable for me. Okay, so on the heat curve, where do we start? We start flat or slanted? Slanted, and this is the solid, okay? And then we flatline, and this is melting. And then we slant, and this is, you're drawing a heat curve. Make sure the person next to you is drawing a heat curve with me. Okay, so this is liquid. And then we flatline, and this is vaporization or evaporation. And then we hit gas. Okay, so on our heat curve, where are we? And this is liquid water, right? We know everything about liquid water. What is this point of liquid water? Because this is the what of water? Right, so that's when fusion begins, which is either melting or freezing. Remember, freezing point and the melting point are both zero, because it's just thinking about going from liquid to solid or solid to liquid. Okay, and then what's this point for water? And that's because that's the what of water. Vaporization point or the boiling point of water. So, we're going from here to here. Where are we at on our graph? Really close to the vapor, right? So, but we're at the liquid. So we're going from 97 degrees here to 100. Well, yeah. So the first part, Q1. I'm just going to call this right here Q1. So that little Q1, that little baby bit right there. What do I have to do calculation-wise? Y MCAT.
Because
Because it's in like a slant.
Because it's in a temperature change region,
Yeah.
right? So I have the M, which is 48, right? I have the C, which, what is that for liquid water?
It's
4.18, blah, 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 it's right here. And then the delta T is what? For this little smidgen of a change right here. No, it's 100 to 97, so that's only a 3 degrees change. All right, so the first Q is in cat. The second Q, the second Q is this right here, which is what? Okay, so that's moles times delta H of what for this particular phase change? That, right? So you guys have HVAP and it's 40.7 what? Kilojoules per mole, right? This is going to be in what? Joules, because the C value itself is in joules. So we're going to have one in joules, the next one in kilojoules. And then you go from 100 degrees Celsius all the way up to what? 190, because that's what the question stated. So you'd have a third Q, and that third Q would be what calculation? But what would be different about this MCAT?
It's 2.05.
Right, so the C of steam is not 4, it's 2.05 joules per gram degree Celsius. And the delta T is what? From 190 down to 100, that delta T is
90.
So I knew you'd forget that. And I didn't want you all to get it wrong, because mathematically you're saying, but conceptually you're not. So you do need to draw a heat curve for anything that goes through a phase change, okay? Okay.
so the correct.
Was not that question. I didn't put it because I knew you guys were going to get it.
Oh, so none of them are right.
It may have been. Okay. What is the melting point of the substance on this heat curve?
It's being produced.
Okay. Good job. Keep it up. Keep it up. All right, 24. Okay. Very good on this heat curve. What is B?
Melting.
That's melting. So the melting point is right here. So you have to draw a line over to the heat curve itself and see it was 5 degrees Celsius. Or 5 degrees. All right. Which regions of the diagram only show potential energy changing? I mean, increasing.
I don't know. Why are we all
Woo, doggies! This thing's so good. All right, so listen. This is temperature, didn't we? In the previous question, I said, what's temperature? What is the definition of temperature? A measure of average kinetic energy. So when temperature is changing, what also is changing? What type of energy, guys? Kinetic energy is changing when temperature is changing. Kinetic energy is changing when temperature is changing. Kinetic energy is changing when temperature is changing. Is kinetic energy changing on B? No, but something is changing. It's the other form of energy, which is potential energy. So potential energy changes here and here because kinetic energy is not, but heat is still being applied, so energy has to change in somewhere for it. Woo! Okay. Keep it up. All right, this is a solved one. Yep. Okay, this is small. Let me read this to you. I'm sorry. Determine the number of kilocalories of heat produced from the reaction of 15.0 grams of calcium oxide with excess water. And it gives you the reaction calcium oxide plus water yields calcium hydroxide plus 15.6 kilocalories. So how many numbers you can use so
It went red. It just went, it just clicked red.
Watch red be red.
If it's right, I'm just
still trying to calculate.
on reaction. Because
That's what I always do.
I have a
If you're calculating, try to knock that out for me.
red side.
This music is subtle. It's very calming. It's not as intense as
All right, let's go behind.
Ooh.
Jules, dun dun.
Let's give it.
Okay, raise your hand if you're one of the 8. Raise your hand. All right, there's 8 of you, and there's 4 hands up. Oh, you're together. Okay, so let's look back at this. All right, back with me. All right, guys, what number do you have to start with? There's only one number you really can. 15 what?
Grams.
Calcium oxide.
CaO. Okay, so I can't do crop grams because all of these are what? Moles, and this is balanced 1 to 1 to 1 to 1. Did you guys see that at least? Okay, this is balanced chemical equation. It's basically saying 15.6 kilojoules of energy is released when 1 mole of calcium oxide is reacted. Okay, so 1 mole of this equals this amount of energy. We just made up an energy mole relationship. But this is in moles, so what do I need to do with this? Convert it to moles. So what's the molar mass of calcium oxide? Okay, so 40-ish for calcium. That's what I said. You might need a periodic table, like 3 people put out a periodic table. So 40 grams of calcium, 16 grams of oxygen, so that's 56 grams-ish per 1 mole. All right, so just approximate this. What's 15 divided by, what's 15 divided by about 55? 3. Okay, so about a quarter to about a third. Okay, so now we have the relationship 15.6 kilocalories per 1 mole. How do I write that here? 1 mole on the bottom. Okay, so then a third of 15. About 5, right? The answer was closest to 4, right? Because we estimated. You truly didn't even calculate, you could guesstimate some. So grams canceled, moles canceled, and then the energy is released. Okay, so I would definitely, hopefully you wrote down some little notes to yourself. You should study some. But here's the reason why. Let me just grab these results real fast. Thanks, guys.
Oh, to see how we did.
Well, I want to see. You need to know how you're doing, okay? All right. Back to me as of here. So I checked this last week because I was going to show you last week, but it didn't work out. So 12/13, which is Wednesday, you have a cumulative test on solutions, which is our unit that we're starting today. Gases, because you only had a gases quiz. You guys still have your gas foldable. You still have your gas notes. And then heat. So heat is you have your gas, your heat foldable, you have your heat notes. So yes, it is a cumulative test between these. And my thinking is I didn't test you on these 2. I'm going to multiply this test grade by 2. It's pretty important, okay? Because it is cumulative. So my guess is that you need to study a little bit of heat just a little bit, but we will be working on unit review. So go back to unit review first. You know the unit review we were just working on? It says thermodynamic review.
Are we going to need to do
Yes, you are going to need to begin, but close them. Wait, you guys know how to turn the battery to balance? Click on battery, not high performance, but go to balance. It'll save their battery a little longer, okay? But let's go ahead and work. We're going to go ahead and work on this. I want you to pick and choose what you want to do so that you guys can get the practice that you personally need, okay?
I don't even know what I did.
Alright, work where you need to on your review. Ask me where you need help.
Yeah.
I'll solve it for you.
Oh, really?
I didn't prefer that.
Yep. It's just the nope. You've already done some of those. Look at the question. Look where it says thermochemistry review. You have to put the units on every single time.
What I'm doing a problem is that I don't really have all
Every single time. Oh, I'll go back to that shortly.
Okay.
Yes. You want to get on desktop? Alright, everybody go to Unit 6 Docs Part Dos. Unit 6 Docs Part 2 for my non-Spanish speaking students. And everybody go here to Molarity Worksheet. Molarity Worksheet. Yeah.
Ooh,
That's like Dora Spanish.
there's a door.
Dora Spanish is like
Okay, guys. Alright, so. Alright, so give me a quick eyes up here so I know you're with me. So, oops, dang it, I pulled the wrong thing up. Alright, so when you pull up the Molarity Worksheet, it looks like this, yes?
Is it on part 2?
Under Unit 6 Docs Part 2. Looks like this. Alright, so our next phase of like concepts we're learning all relates to solutions. So we talk about like what's in the solution, what's the concentration of the solution, what can you do with the solution, how is it different from other solutions, how does it affect the real world. So it's just all about solutions. So if I say solution, give me one real world example of a solution.
Water.
Lemonade, great. What else? Water is just a solvent, right? It's not dissolving anything. Kool-Aid, what else?
Tea.
Hot chocolate, sweet tea, Gatorade, anything that's a drink you drink probably has stuff dissolved in it, right? So basically, you need to make sure we're very clear on what it means to be a solute, a solvent, a solution. What does it mean to be concentrated versus dilute? How do I numerically describe that, and so forth. So take 10 minutes on this one. Get through question 10. Go.
10.
10.
Oh, we only have to do 2 questions?
Right now, do through question 10. Let's go. Why do you question me when I give you a set of instructions?
So, like, we know that you're, like...
You're making sure you're clear.
You're being thorough, so, like, just in case you, like, question 10 more times.
You want me to go through question 20?
Oh, no, I'm good.
No.
Yeah, just write it on the board so we don't got past it.
You're good. You're good.
I don't want to be, like, doing 1 through 20.
1 through 10 right now. Yes, write this out. Go short and sweet, please. I don't care for complete sentences. Short and sweet, okay?
No one is done.
No. I don't have
I'm not even mean to you.
Guys, stop being mean to each other like you're brothers and sisters.
pretty nice. Brothers, yes.
No, I did like 50%.
It's been late tomorrow.
No. By the way,
Process, group, and create.
Wait, isn't the song the ones like it's the what's the lemonade thing? The powder. Oh, can I just call it powder?
I'm going to get a drink really quick.
You what? Once? Then you get a little creepy hands on me. The money is so hot. Oh wait, hold on. The bathroom. Other kid, you go to the bathroom.
What is dissolved lemonade mixed represent? Black thing, black dot. Are you gonna go over this? Sorry, no, I gotta water. I'm gonna go over it. Your class goes by so fast. Like, we learn so much.
Flip back to the first one for me.
Ooh, that was a shaky one. I feel like it's full.
I was looking at answers. Alright guys, I need you back in your seats in 10, 9, 8, let's go.
7, 6, 5, 4, 3, 2, and 1. Oh wait, I'm not sitting down. Wait, 1.5. 1.5. 0. No, I'm good.
Alright guys, be quiet. Ladies and gentlemen, I'll wait on you. I don't have to hold you after the bell. I might have to if I can't get your attention. Alright, so today I was a little disappointed in some people's productivity and off-taskness. Okay? I know that you want to chit-chat, but I'm trying to give you some time to work in class so you're not doing as much at home. Doing this in class makes reading guide 15-16 much easier because you have a good background. Makes it less stuff to look up in the book. Okay? So if you did not finish this, raise your hand. Okay, you had ample opportunity to finish that, but you were off task. Okay? So if that now brings you to after school detention, that's on you. But some of you guys were working hard. I know you didn't quite finish. I'll give you like 5 or 6 minutes tomorrow to finish that, okay? But what I want you to do for homework is reading guide 15-16. 15 is all about water. We're only going to spend about 15 minutes on water tomorrow. And the rest, 16 is on solutions. Some of this you'll know, some of this you'll need to look up. Wait 1 second. If you have not sent your professional email yet, you are not going to finish this project. You need to do that ASAP. Send me questions back.
I'm doing my like interview thing tonight.
Good. Where's Matt?
Yeah, she's gonna like help me. I'm gonna record what she says, and then we're gonna like both write down the answers. And I'm gonna put it in the self. I'm gonna put like a balance of thought.
I see for interview questions. Okay, thanks.
So one person hasn't emailed me back, and I emailed them like on Saturday, like midday Saturday. So I already have a little bit of background information. Should I go ahead and start? They should be. They work at my mom's job, so they should be. Alright, thank you. What?
Let me shut my video. I'll upload that.